Chapter 5. Arithmetic Progression. This presentation on arithmetic progressions will cover the following topics: an introduction to patterns and sequences, a definition of arithmetic progressions, or APs, how to find the nth term of an AP, how to calculate the sum of the first n terms of an AP, a summary of the key concepts. Introduction. We can observe patterns all around us, from nature to our daily lives. For example, a salary that increases by 500 rupees each year forms a pattern: 8,000, 8,500, 9,000, and so on. The lengths of rungs on a ladder that decrease by 2 centimeters also form a pattern: 45, 43, 41, and so on. In this chapter, we will learn about a specific type of pattern called an arithmetic progression. Arithmetic progressions, AP. An arithmetic progression is a sequence of numbers where each term after the first is found by adding a constant number to the term before it. This constant number is called the common difference, represented by D. Here are some examples of APS, 1, 2, 3, 4, and so on, where the common difference is 1, 100, 70, 40, 10, and so on, where the common difference is negative 30, 3, 3, 3, 3, and so on, where the common difference is 0. The common difference D can be a positive number, a negative number, or 0. General form and types of APs. If we let A be the first term and D be the common difference, the general form of an AP can be written as A plus D, A plus 2D, A plus 3D, and so on. APs can be either finite or infinite. A finite AP has a limited number of terms, like the heights of students in a class. An infinite AP has unlimited terms, like the list of positive numbers 1, 2, 3, 4, and so on. Finding terms and checking for an AP. If you know the first term A and the common difference D, you can determine the entire AP. For example, if A is 6 and D is 3, the AP is 6, 9, 12, 15, and so on. To check if a list of numbers is an AP, you must verify that the difference between any two consecutive terms is constant. Example 1. Finding A and D. For the arithmetic progression, 3 over 2, 1 over 2, negative 1 over 2, negative 3 over 2, and so on. Let's find the first term, A, and the common difference, D. The first term, A, is 3 over 2. The common difference, D, is the second term minus the first term, 1 over 2 minus 3 over 2, which equals negative 1. Example 2. Identifying an AP. Let's determine which of the following lists form an AP. 4, 10, 16, 22. The difference between consecutive terms is always 6. So, this is an AP. The next two terms are 22 plus 6, which is 28, and 28 plus 6, which is 34, 6, which is 34. 1, minus 1, minus 3, minus 5. The difference between consecutive terms is always negative 2. So, this is an AP. The next two terms are negative 5 plus negative 2, which is negative 7, and negative 7 plus negative 2, which is negative 9. Continuing example 2. Negative 2, 2, negative 2, 2. The difference between the second and first term is 4, but the difference between the third and second term is negative 4. Since the differences are not the same, this is not an AP. 1, 1, 1, 2, 2, 2. The difference between the first few terms is 0, but the difference between the fourth and third term is 1. Since the difference is not constant, this is not an arithmetic progression. The nth term of an AP. To find any term in an arithmetic progression without listing all the terms, we can use a formula for the nth term, which is denoted as a subscript n. The formula is a sub n equals A plus, in parentheses, n minus 1 times D, where A is the first term, n is the term number, D is the common difference. Example 3. Find the 10th term. To find the 10th term of the AP, 2, 7, 12, we use the formula. Here A equals 2, D equals 5, and n equals 10. The 10th term is 2 plus 10 minus 1 times 5, which equals 47. Example 4. Find the term number. Which term of the AP, 21, 18, 15, is negative 81? Here, A equals 21 and D equals negative 3. We set the nth term formula equal to negative 81 and solve for n. The result is n equals 35, so the 35th term is negative 81. Is any term 0? We set the formula to 0 and solve for n, which gives n equals 8, so the 8th term is 0. Example 5. Determine the AP. Let's determine the AP whose third term is 5 and seventh term is 9. We can set up two linear equations. The third term gives us a plus 2d equals 5. The seventh term gives us a plus 6d equals 9. Solving these equations gives us a first term, a, of 3 and a common difference, d, of 1. Therefore, the AP is 3, 4, 5, 6, 7, and so on. Example 6. Check if a number is a term. Is 301 a term in the list? 5, 11, 17, 23. First, we confirm this is an AP with a common difference of 6. We let the nth term be 301 and use the formula to solve for n. The calculation gives n as 302 divided by 6, which is 151 divided by 3. Since n must be a positive integer, 301 is not a term in this arithmetic progression. Example 7. Two-digit numbers. How many two-digit numbers are divisible by 3? The list of these numbers is 12, 15, 18, and so on, up to 99. This is an arithmetic progression with a first term of 12, a common difference of 3, and a last term of 99, 3, and a last term of 99. Using the nth term formula, we set the last term, a subscript n, to 99 and solve for n. This gives us n equals 30. So there are 32 digit numbers divisible by 3. Example 8. Finding a term from the end. Find the 11th term from the last term of the AP, 10, 7, 4, down to negative 62nd. First, we find the total number of terms in the AP. With a equals 10, d equals negative 3, and the last term L equals negative 62. We solve for n and find there are 25 terms. The 11th term from the end is the same as the 25 minus 11 plus 1, or 15th term from the beginning. We then calculate the 15th term, which is 10 plus 15 minus 1 times negative 3, equaling negative 32. Example 9. Simple interest. A sum of 1,000 rupees is invested at 8% simple interest per year. Does the interest at the end of each year form an arithmetic progression? Let's calculate the interest for the first few years. Year 1, 80 rupees. Year 2, 160 rupees. Year 3, 240 rupees. The sequence of interests is 80, 160, 240. Continuing example 9 and example 10. The list of interests forms an AP because the difference between consecutive terms is always 80. To find the interest at the end of 30 years, we find the 30th term of this AP. The 30th term is 80 plus 30 minus 1 times 80, which equals 2400 rubai. Example 10. Flower bed. In a flower bed, the rows have 23, 21, 19 rose plants, and so on, with 5 plants in the last row. This forms an arithmetic progression where a equals 23, d equals negative 2, and the last term is 5. We use the nth term formula to find n. The calculation shows that n equals 10. So, there are 10 rows in the flower bed. Sum of the first n terms of an AP. The sum of the first n terms of an AP is denoted by s subscript n. It can be calculated with the formula s subscript n equals n divided by 2, multiplied by the quantity 2a plus, in parentheses, n minus 1 times d. If you know the last term, nl, you can use a simpler formula. S subscript n equals n divided by 2, multiplied by a plus l. Also, the nth term of an AP is the difference between the sum of the first n terms and the sum of the first n minus 1 terms. Derivation of the sum formula. The formula for the sum of an AP is derived by writing the sum of the n terms, writing the same sum in reverse order, adding these two expressions together, which results in n pairs, each summing to 2a plus n minus 1d. This gives 2 times s subscript n, which is then divided by 2 to get the final formula. Example 11. Find the sum. Find the sum of the first 22 terms of the arithmetic progression, 8, 3, negative 2. Here, a equals 8, d equals negative 5, and n equals 22. Using the formula, the sum is 11 multiplied by 16 minus 105. which equals negative 979. Example 12. Find the 20th term. If the sum of the first 14 terms of an arithmetic progression is 1050 and its first term is 10, what is the 20th term? First, we use the sum formula with the given information to find the common difference, d. The calculation gives d equals 10. Now that we know d, we can find the 20th term using the nth term formula. The 20th term is 10 plus 20 minus 1 times 10, which equals irnutavde. Example 13. How many terms? How many terms of the AP, 24, 21, 18, must be taken so their sum is 78? Here, A equals 24, D equals negative 3, and the sum S subscript n is 78. We set the sum formula equal to 78, which gives a quadratic equation. N squared minus 17n plus 52 equals 0. Solving this gives two possible values for n, 4 or 13. Both answers are possible because the terms eventually become negative and the sum of the terms from the 5th to the 13th is 0. Example 14. Sum of positive integers. Let's find the sum of I, the first 1000 positive integers. Using the formula S subscript n equals n over 2 times a plus l, the sum is 1000 divided by 2, multiplied by 1 plus 1000, which equals 500,500. P. The first and positive integers. The sum is given by the general formula, S sub n equals n times n plus 1, divided by 2. Example 15. Sum from the nth term. Find the sum of the first 24 terms of a list of numbers where the nth term is given by a subscript n equals 3 plus 2n. First, we find the first few terms. a1 equals 5, a2 equals 7, a3 equals 9. This forms an arithmetic progression with a equals 5 and d equals 2. We then use the sum formula to find the sum of the first n terms, 24 terms, which is 672. Example 16. TV production. A TV manufacturer's production increases uniformly each year. They produced 600 sets in the 3rd year and 700 in the 7th year. This forms an AP. We set up two equations, a plus 2d equals 600 and a plus 6d equals 700. Solving these gives a first-year production, A, of 550 sets and a common difference, D, of 25 sets. The production in the 10th year is the 10th term, which is 775 sets. The total production in the first 7 years is the sum of the first 7 terms, which is 4,375 sets. Summary. Here are the key points from this chapter. An arithmetic progression, AP, is a list of numbers where each term is found by adding a fixed number, d, to the term before it. This fixed number is the common difference. The general form is a plus d, a plus 2d. A list of numbers is an AP if the difference between consecutive terms is always the same. The nth term of an AP is given by the formula, a subscript n equals a plus n minus 1 times d. The sum of the first n terms is given by S equals n over 2 times the quantity 2a plus n minus 1 d. Thank you for learning with us.